So in the last lectures we have seen the crushing laws and the problems involved in the crushing law. So the field of appropriate size was given to us, and then after the crushing is over, the product was subjected for sieving, and then after sieving we have tabulated the results in the tabular column to find the value of the average product size. Then after knowing this, we started applying the three laws or any one of the law which is stated in the problem, and then we found the power consumed in some cases, and in some cases there were two cases were given. So in the first trial, we found the values of the Rickinger's constant or Bond's constant or Fick's constant, and the next step we applied this to find the value of power consumed. So this is what we have done in the last classes. So now we will dedicate our time in studying the equipments. So here, whatever the equipments are there, they are there in our MUO lab, and we will be performing experiments on these instruments only. So we are in a subject called as size reduction, and now we are going to start the equipment. What are the equipments which are there in our chemical industry, and some of them which we have seen only a small diagram in our chemical technology one, but here we have to understand and then study, draw it, and then understand the working principle of the different types of size reduction equipments. So we'll start with this column, size reduction equipment. Size reduction, and before that also I will show you that the particles are broken down by means of compressive forces, by means of impact, by means of attrition or shear forces, and lastly by mere cutting also we can reduce the size of the particles. And we also know that there are four categories of particles are there. One, the one which is measured by means of inches or in centimeters. The second one is in screen number, mesh number. The third one is in nanometers, and the last one is of course millimeter square per gram. So millimeter square per gram is the smallest unit of measuring a size of a particle. So with this note, let us see the text of size reduction equipment before we see the first equipment. Size reduction equipment is divided into crushers, grinders, ultrafine grinders, and cutting machines. So these are the four broad classifications of size reduction equipments which are there. You take the ores. There also we have crushers. Online crushers are there. Then they are reduced to some sizes which are easy for us to transport from the ore to some other place. Then afterwards, again we are supposed to reduce their sizes as the process demands or as the consumer demands. We try to use different types of equipment. But whatever the equipments are there in the size reduction equipment, they are broadly classified as crushers, grinders, ultrafine grinders, and cutting machines. Crushers do heavy work of breaking large pieces of solid into small lumps. A primary crusher operates on run-of mine. Mine means here it is whether it is a coal mine or alumina bauxite mine, etc. Run-of mine material, accepting anything that comes from the mine face and breaks it up to 150 to 200 millimeters long. So this is the definition of a crusher. So crusher is the first instrument which we are going to use it. So generally what we do is we blast the mines, and then there we are going to get a different size of the particles. So depending upon the different size of the particles, now they will be sent to the primary crushers first. So basically in a crusher what will happen, there are two hardened jars are there, and these jars will be applying compressive forces on the particle, and as you know the particle cannot withstand the applied force, it breaks into pieces. So there our prime aim is to reduce the size of the ores. So once we blast the mine, we may get different types of sizes, and these sizes are going to be crusher by means of conveying systems. So at the mines we have the crushers, that is very important. And then the primary crusher, which is near the mine, it accepts any types of soil particles and then definitely it will give 6 to 10 inch lumps of particles. And secondary crusher reduces these lumps to perhaps 1 by 4 in size. So this is what the primary crusher will be doing it. So they will be using compressive forces in reducing the size of the particle. Then grinders. Grinders reduce crushed feed to the powder. So whatever the product is obtained in our crushers, whatever the product is obtained from the crushers, now that is sent to the grinders. If you remember, I said that it is not possible for us to reduce the size of very large size particles to very small size. So we are supposed to follow a hierarchy of equipments. So a series of equipments are used. We are supposed to use sieving, we are supposed to remove the fines and then send them to some other unit, and then oversized particles should be recycled back. So ultimately, whatever the size of the particles are obtained or accepted by the customer, that will be accepted. Rest will go as a losses. So now after seeing what is a crusher, then we go for the grinders. In the grinders, what happens is that the product which is obtained from a primary crusher or secondary crusher, now that is sent to the grinder, where it crushes feed to the powders. And now the product from an intermediate grinder might pass through a 40 mesh. So already what will happen? The inches have suddenly become mesh numbers. Means from first category we came to the second category, where the product of the grinder is now sent to the grinder. So the product of the crusher is sent to the grinders, and then after grinding is done, what will happen? The product is now eligible to be called as dash mesh number, whether it is 20, 100, whatever it is, depending upon the character of the grinder, we give the size to the part. Most of the product from fine grinders pass through 200 mesh with a 74 micrometer opening. So as I said that, if somebody asks you what is the basis for Taylor standard screws, you should say 200 mesh with a clear opening of 0.074 millimeters. Okay. So this is what we are supposed to, this is how we are supposed to construct the tabular column for the sieving. Now here what he says is most of the product from the fine grinder would pass through 200, means in the grinder we have again some fluctuations are there, primary grinder and ultra-fine grinder. So the first what we get the product from the crushers, now that is sent to the grinder. In the grinders after grinding is over, the product is now called as dash mesh number, 100 mesh number, 200 mesh number, 20 mesh number, etc. etc. because their sizes are very small. Now from there if you send it to ultrafine grinder, then of course the size will be around 200 mesh. Now an ultrafine grinder accepts to feed particles no larger than half inch, and the product is typically 1 to 50 micrometers. So you can imagine what is the reduction ratios here. Cutters give the particles of definite size and shape 2 to 10 millimeters in length. So cutters will be giving perfect shapes to it. So we have only one example in our mechanical operations. It is called as a rotary knife cutter. Okay. So in your house, of course, if you have an onion cutter, that is the best example of a rotary knife cutter, where we have two jars are there. In the top jar we have some blades are there, and then we have a mesh. Okay. And then once you put the onion and then start rotating it, what will happen? Cuts into pieces, and the pieces now passes through the screen and they falls to the bottom. This is the best example of a rotary knife cutter. Only one is there in our subject that we'll see in the next stage. So the principal types of seismic machines are as follows. Now the first one, now here we have given the classification. First one is called the crushers, grinders, and then the second one is ultrafine grinders, and the fourth one, that is the last one, D, is the cutting machines. So now what is the crusher? Crusher is what? It takes any types of feed and then it crushes to some sizes which are measured in terms of inches or in centimeters. So hence coarser grinding is taking place. So hence we call it as a coarse on fine. Why fine is that? Because we are dealing with heterogeneous materials. When we try to apply the force on the particles, there is also guarantee that we may get very small particles also. Okay. So means what? From the crusher, if you do sieving, after doing sieving, you will have some particles in the fines also. So it doesn't mean that all the particles can be measured in terms of inches or in centimeters. Some particles will fall in the fan also. So hence he has written fines also. What are fines are? The particles which are passing through the screen in a given mesh number is called as fines. Particles which cannot pass are called as the oversized particles or tails. Very good. So here we have three examples: jaw crusher, gyratory crusher, and then crushing rolls. So three examples are there. And from there we move to the category number B, where we have grinders. Intermediate to fine crushing will take place in this. And here the examples are hammer mills, impactors, rolling compression mills, ball roller, roller mills. Third one is attrition mills. Fourth one tumbling mills, rod mill, ball mills, pebble mills, tube mills, compartment mills. And finally, we have ultrafine grinders, hammer mills with internal classification, fluidized energy mill, and agitated mill. So these are the two categories which will be giving very small size particles: fluidized energy mill and agitated mill. Okay. And finally, we have one example: decutting, where we can use knife cutters or dicers or splitters. Okay. So with this changing the blades, we can give the shapes to the given material. So basically, these are the four categories. The first one is called as the crusher, second one is called as the grinder, third one is called as the ultrafine grinder, and fourth one, the last one, is called as the cutting machines. So let us see one by one in detail. Now these machines do work in distinctly different ways, because see, as the size of the particle is decreasing, I said it is very difficult for me to nip the particle. Remember, catching the particle is called as nipping. So to catch the particle is difficult. Suppose if you take a very coarse, a big particle, catching the particle is easy, then we can apply the force. It will break. But as the size of the particle decreases, it becomes difficult for us to catch the particle. So hence the technology which is involved, the process which is involved, the how we are going to apply the force on the particle to break it is also different when compared to crushers to grinders to ultrafine grinders. And the last one, of course, I said it is a unique category. We will discuss it only at the end, because it will be using knife, scissors to cut into its pieces. Whereas the difference will be there in the three categories. That is, the first one is crushers, second one is what? The grinders, and the last one is ultrafine grinders. Grinders employ impact and attrition. Impact is what? Application of a huge amount of force on a particle for a short duration. Best example is hammer. So with the help of a sledgehammer, we can apply large quantity of force on a specimen for a shorter duration of time. It breaks into pieces. Then attrition means what? We have a chakki or tiragal in the house where the bottom one is not moving, bottom stone is not moving, but the top one will be moving. So when you put the grain photographs in between, the shear forces will be applied on surface area of the grains. Thus the size reduction takes place, and further grinding will also take place, and then we get fine powders of the wheat or whatever. So that is the attrition here. And there can be, as I said, there can be a combination of it, or it can be using only one type of force. Now sometimes combined with the compression is also there here. Then ultrafine grinders operate principally by attrition. So in the ultrafine, as I said, that as the size of the particle is decreasing, it is very difficult for us to catch the particle. So now we have to still reduce it. How to reduce it? So what we do is generally in the fluidized energy mill or in the agitated mill, we add these all particles, small particles, and then we add pebbles or stones, and then we vibrate it with a high frequencies for some amount of time. So that what will happen, in between the particles in this type, what will happen, they will break into pieces. Okay. And in the fluidized energy mill, we use high pressure steam, and that will be injected to various nozzles to create a turbulence, and then we introduce this small salt particles, and they'll be going in a loop. So by pushing each other or pushing with the walls of the container, the size reduction takes place. So as I said that as we try to go down, what will happen, the efficiencies are decreasing. We will see it in the theory part. And then the next one is cutting action is, of course, characteristics of cutters, dicers, and splitters. So these are the ways how the machines are working. So let us see one by one in detail. The first one is the crusher. In the crusher, the first one is the jaw crusher. Yes, crusher. Crushers are slow speed machines for coarse reduction of large quantities of solids. Coarse reduction means what? The feed is also measured in inches and in millimeters, and similarly the product is also measured in majority of the product. I say majority of the product will be measured in terms of inches or in millimeters. Okay, so these are the examples of the crushers. Crushers are low speed, means for the jaws which are operating, they will not operate very fast, but they will be operating very slowly or moderately depending upon the nature of the material. Crushers are slow speed machines for force reduction of large quantities of solid. So once the mine is blasted, there will be different types of solids or particles will be there. So they with the help of a tractor line, sorry, drag line or with a tractor shovel, these particles are put on a conveyor belt, and this conveyor belt goes to a particular head. From there it discharges the materials into the crusher, and then the crushing will be taking place. We have to give some time till the particles are coming down. Remember, MEO lab generates a lot of noise because during crushing the particles loss of energy, the energy which cannot be taken by it comes out in the form of sound. And as I said, efficiencies are very less. Definitely, you will have large amount of sound when the particles are breaking. So now, how to dose the solid particles into the machine is very important. So once you drop a solid particle into the crusher, you will be hearing some noise. So as the noise is completed, then you should introduce second one. So this is how we introduce a continuous feed in a laboratory, because in the laboratory we cannot have a conveyor belt or some phenomenon by which we can send m dot, we can keep m dot as constant. So manually we are supposed to charge it. So the best method is when you are charging a solid particle, you will be hearing some noise. Before the noise comes to the end, you should add the second one. So this is how we have maintained the continuity, because m dot is also a very important factor in the power consumption formula. You take Rigdon's law, Bond's law, Fick's law. If m dot is increasing, the power consumed will decrease, because m dot is denominator. So when the denominator is increasing, the fraction value what will happen, it decreases. So we may not get the correct value of the power. So m dot is very important, and how we are supposed to charge it to the feed is important. But in industry it is not possible. So in the industry what they will do, they will be keeping a conveyor belt, and the conveyor belt moves and then discharges the materials into the crushers through hoppers or silos, whatever. Crushers are slow-speed machines for coarse reduction of large quantities of solids. The main types of jaw crushers, gyrated crushers, smooth roll crushers, and toothed roll crushers. So these are the categories which are available in the crushers. The first three operate on the compression. That is, compression can be obtained, can be an act of compression will be there when you try to apply compressive forces by means of some elements. Okay. And can break into large lumps, very hard materials, as a primary secondary reduction of rocks and the ores. As I said that basically the primary crushers or these crushers are used for ore materials. So as I said that just now, that lumps of different sizes will be added to it, but they will be crushed satisfactorily in these machines. Then toothed roll crusher tear the feed apart as well as crushing it. They handle softer feeds like coal, bone, and soft shell. Bone and soft shell. Coal, soft shell is used for the supplementing calcium in the tablets, and bone is for bone char, which is also used sometimes in purifying the sugars, etc. Whatever. Then let us see the first diagram of a jaw crusher. So before we see the jaw crusher, let us see the diagram of a jaw crusher, because this is the first diagram which you are supposed to draw in your diagram, in your laboratory record. So I will read the names for you. Blade type of jaw crusher. There are two types of jaw crushers are there. Blade type of jaw crusher, Dodge type of jaw crusher. DODGE, Dodge type of jaw crusher. Now, stationary jaw, hardened jaw faces, swinging jaw, pivot, eccentric, pitman, flywheel, spring, and then toggles, and then discharge. First, most important thing is this line. So this line, if you see, this is made up of the hardest material. A stone is made like this, and then these are called as jaws. These are the points from where we apply some forces on the object. And remember, this gap is like a V shape. So as you try to go down, what will happen? The clear opening is decreasing. So this one is called as the hardened jaw face, and this is a stationary jaw, means what? It is not moving. Whereas this is called as a swinging jaw. So swinging jaw will be swinging in this direction. This will be moving like this. So here at the top, it is fixed by means of a pivot. Pivot means what? A bicycle. A bicycle will have a pedal and the pedal is connected to a steel rod, and the steel rod is connected to the axial at the center. So the axial and the steel rod are connected by means of pivot joint so that it can move in a circular fashion. So that is the example of a pivot joint. So with the help of this pivot, if you keep a pivot joint here, what will happen? The bottom one is free. So the bottom is connected by means of these toggle plates to this one. And here, this entire system will be moving by means of this shaft. And what is the meaning of eccentric, sir? Eccentric means what? Which is not a concentric. Means what? Both the centers of the circles, if they are meeting with each other, we call it as a concentric. Means best example is in the Flash process, you can see concentric pipes. In the Kellogg's process also you can see concentric pipes. But suppose if the centers are not same, then that is called as eccentric mechanism. So eccentric mechanisms are used for the purpose of converting torque to vertical reciprocations. That is the phenomenon of machines. I repeat once again, the eccentric mechanisms are used for converting torque is rotating motion to what, sir? To the vertical reciprocations. Reciprocation is what? Moving left hand side, right hand side in a fixed cycle is called as reciprocations. So this eccentric will take care of that. So we have a circular shaft and then we have a flywheel. This side of your computer screen, you will be having an electric motor which is driving it. So this shaft will be rotating. As the shaft is rotating, what will happen? Yes, this eccentric mechanism will move like this because it is not connected. You see the gap that indicates is not center. So that will be moving top and down like this. And when it is moving like this, what will happen? Because of this connecting plates, here you have a spring, here you have connected to the swinging jar. So the swinging jar will be moving in this particular fashion. Remember this. So in your engineering drawing, if you have drawn the diagram of a slider crank mechanism, so the diagram will be there in what do you say, ND butt. In the unit 1 it will be there. So if you have the textbook, if you see that, you will understand this one. So slider crank mechanism is used where circulatory motion is converted to the reciprocations. So like that only, this is also obtained. So remember, the flywheel is what is the function of flywheel? Because if you put any hardened, means what this is designed for coal ore. For example, we have ores of coal that you can put it. But suddenly if somebody is putting some materials, composite strength is very high. In that case, what will happen? It will enter the system, but crushing will not take place because the entire system will lock it because it is not able to apply any forces, but the machine is running. So under such kind of situations, what happens is that this entire setup will go back. The relief spring will be released, and this toggle, this connecting rod will go back. And when then what will happen? Because of the gravity, the solid material will fall because of the gravity, goes out from the system. But what will be happening to the energy given to the motor? That will be stored in the flywheel, because you know very well, in a two-wheeler, when you catch the clutch, what will happen? The petrol is burning, the motor is running, but it will be stored into the flywheel, remember this. And once you release the clutch, what will happen? The energy will be transferred to the wheel, and the wheel rotates. This is the mechanism of it. Similarly, here the flywheel is also used whenever a hardened foreign material. What is the foreign material, sir? Here, the material whose composition strength is more. We have designed this for 1 kilonewton per meter square. But suppose you put a material with 100 kilonewton per meter square, that is a foreign material for me. For that, I use some other crusher, not this one. Remember this. So, for such kind of materials, if they enter accidentally, we have a mechanism that will not destroy the faces of the jaws. But what will happen, sir? This connecting rod goes back, because why? This cannot advance in the forward direction. So hence when it goes back, the release spring will be open, this core system, and because of gravity, it falls from the bottom into the discharge. Okay. So that is this. What is the fitment? Fitment is nothing but the connecting rod, the connecting item. That I said that in the bicycle, if you see the side view. So this is the diagram which you are going to see. So here you have a pedal, and this is your shaft. And then when you try to push the pedal, what will happen? This will be moving in this fashion. Okay. So here what will happen? This is connected to electric motor. When the electric motor is rotating, what will happen? Since these are the two constraint toggles, what will happen? This will be moving in this fashion. So ultimately, we should understand here one point that in the V shape, when we add the solid particle, the swinging jar goes back. When it goes back, what will happen? The area of crushing increases, and there is no crushing is taking place. But when the swinging jar is coming towards the stationary jar, then the area is decreasing, and then we can catch the particle, then only it will apply the force on it. So what I say with this is, in a blade type of jaw crusher, the product may not be continuously falling down, but at a cycle, when the swinging jaw is moving towards the stationary jaw, crushing will take place. When the swinging jaw is going away from the stationary jaw, crushing will not take place. That's what we are supposed to understand. And remember, the method of going this side and coming back are called as gyrations. And around 450 to 600 gyrations per minute this machine will be making. So you can imagine how vigorous the crushing will be taking place. So this is about the first equipment called as blade type of jaw crusher. Okay, I'll repeat it once again. Here we have a jaw crusher where we have two phases. Two phases means what? Something is necessary for us. So for example, if you want to work on a steel rod, or if you want to put threads on a pipeline, what you should do? You should have a bench vise first. In the bench vise, there are two hardened faces are there. First, you put that object in between them and then rotate the capsule screw. What will happen? The bench vise will tighten or firmly fix it. So hence, through that we apply the force and then we start working on it. Remember, after tightening the capsule screw tightly, then we start working on it. Similarly, here also there are two phases are to be required by the machine where I can apply the compressive forces on the object and the object can reduce its sizes into pieces. Okay, very good. So what are those ones? They are called as the hardened phases. So here we have one phase. Here it is also we have one phase. So if you see the side view of it, they are nothing but rectangular plates. Remember, they are nothing but rectangular plates. So in your house, fortunately or unfortunately, if you have a checky, the two plates, if you see, they are circular discs, isn't it? So these circular discs are made up of what? Hardened material, stone. That is very important. Like that here also, if you see the side view of this one, where I am putting this cursor, you see a rectangle. And remember, it is not a smooth in surface. It is having corrugations. Means what? I have to induce friction compulsorily. Because if friction is there, then only I will be able to catch the particle firmly. Then I will be applying the forces for breaking the particle into pieces. So on the vice versa, if you have a smoother surface here, crushing will not take properly. So hence, conclusion is what? The hardened jaw faces are having some amount of area, and on their face they carry the corrugations or stampings for increasing the value of friction. Then the first one, that is this plate will be stationary, which is not moving, whereas this one will be moving. So how this one will be moving, that is important. So at this point, this is pivoted and determines what? This cannot move in this. So there will be, the movement will be like this. Remember this, like swinging, it will be there. So during the swinging, what will happen? The swinging jaw will be moving from left hand side to right hand side. Then of course the material will come inside, and then after certain time from right hand side to left hand side it will go. Then it is coming towards the stationary jaw. The area is decreasing. So hence we can catch the particle, and since it is made up of a hardened phase, and then we are applying a force with a heavy electrical motor, then of course the particle crushes and then falls here from the gap from the bottom. It goes out. Very good. But now the point is how this is able to swing, because we cannot keep a human being here. So hence what I do is I require a mechanism for it, and that mechanism will be having some elements called as eccentric, pitman, flywheel, spring, and toggle plates. So these are the mechanisms which are supporting the swinging action of this phase. So now this is at the pivot at the top. So I gave the example of a pivot, the bicycle. Okay. So pedal is connected to a connecting rod, steel rod, and the steel rod is connected to the axle, isn't it? So that is the example of a pivot joint. Then coming back to this, the same pivot joint will be there, but this is at the center, but this is not at the center. At off center means what? We are not going to fix them at the center. So we create a gap here and then we put it, and then afterwards we fill the gap. And once you start rotating the shaft, what will happen? Now how this will be rotating, that is important. So this will be moving in the circular direction, but in a very short radius. And because of it, what will happen? This is moving and coming down. So this will be moving in this particular fashion. Remember, the movement is not in inches or anything else. Here the frequencies are very small, means what, minor gaps will be there. Our aim is to move this slightly. Please don't think that this will move to this particular point by some inches and then comes back. It is very small, remember. So when you see our real-time equipment, so you will understand. Then suppose unfortunately if I put a hardened material, then as I said that the jaw will go back because of this connecting rod, the spring is there, it goes back, and then the particles falls because of the gravity. Then the operator will stop the machine and release the spring, and then again it will put into the work. Then during the due course of time, you cannot stop the instrument suddenly, so hence the damage will not be there to the faces, but of course the energy is stored in the flywheel. So what is the role of a pitman? Pitman is a robust steel rod which connects the eccentric to the toggle plate. These are the heavy toggle plates which are present at the back. So which will, because of it only, the movement is transferred from this pitman to the swinging jaw. So a swinging jaw cannot move here, simply it moves like this. Remember, like this it will be moving, remember, okay? So but it will not move this direction. Small variation is also sufficient, because I said around 400 to 500 gyrations there will be there for a minute. So that is sufficient to crush the material. And initially we see here, why this V shape is there, because initially when we send the particle, so here we have a limitation. So the distance between these 2 points is, say for example, 10 centimeter. So if you put 20 centimeter particle, that will not be falling into the system. Only 10 centimeter will go. So remember always, if you have a size of uniform feeds, if you have a feed of uniform sizes, it is always good for us for increasing the efficiency. If we have a feed of very different sizes, for example, the opening between these two is 10 centimeters. You are putting 1 millimeter particle. What will happen? It will easily pass through it. Energy is given to the machine, crushing is not taking place. So in order to avoid this kind of discrepancies, let us put one assumption that the size of the feed which is going to the crusher, it should be uniform. Then only the process of crushing will be successful. Then from here it falls onto the discharge, it goes up. So as we put 10 centimeter particle, after crushing is over, 10 centimeter may become 5 centimeter. So if these were two parallel lines, then of course after crushing, 5 centimeter particle will also go from the bottom. So we should ensure that as we try to go down, the crushing area should decrease. When the crushing area is decreasing, what happens? The particle will have another chance to take the blows of the hardened faces and then break into smaller sizes. Unless and until its size is equivalent to less than this, it will be staying inside the system, takes the blows, and then becomes, when the size becomes less, then only it comes from the bottom. So this is the first example of a Blake type of jaw crusher. In the Dodge type, this is just the pivot will be at the bottom, and the swinging stationary jaw is like this only, but the swinging jaw will be moving in this fashion. So if you see here, that will be moving like this. So hence, there is no restriction is there in the feeds of different sizes. So a Dodge type of crusher can accept sizes of different feeds, but there will be a problem will be there. What is the problem, sir? Here you have a crushing jaw, swinging jaw. So pivot is at the bottom. So this arm will be coming this side, and when the opening is maximum, if a heavy lump is falling here, what will happen? This jaw may not go in this direction. So hence it will be struck, and then immediately the relief valve will be opened and the energy will be stored in the pitman. So that indicates that in the Dodge type of jaw crusher, there is a frequent problem of choking. So hence the design has become absolute, and now all the jaw crushers will have only Blake type of jaw crusher, which accepts feed of constant sizes. Okay, and from there, after crushing is over, it will be falling from the bottom. So this is what we are supposed to understand from the Blake type of jaw crusher. Let us see the theory part of it, and whenever it is essential, I will be coming back to this particular diagram. Yeah. So here, a jaw crusher. In a jaw crusher, the feed is admitted between two jaws. Yes, one is called as the stationary jaw. The second one is called as the swinging jaw. So in case of a Blake type of jaw crusher, the pivot is at the top In case of the Dodge type of jaw crusher, the pivot is the bottom. So these are the differences. It will come in the bit paper. List out any 3 differences between Blake type of jaw crusher and Dodge type of jaw crusher. The first point is the pivot is at the top for the Blake type of jaw crusher. The pivot is there at the bottom for the Dodge type of jaw crusher. Feed of various sizes can be accepted in case of Dodge type of jaw crusher, and it is not possible in the Blake type of jaw crusher. Blake type of jaw crusher is not subjected for choking, but Dodge type of jaw crusher is subjected for frequent choking. So in a jaw crusher, feed is admitted between 2 jaws. There only you are supposed to admit, because in this between these 2 jaws only the process of side reduction is taking place. Set to form a V shape at the top. So at the top, farmers, if you try to come, we have seen the diagram already, there will be a V shape is there. So that initially at the head end of the V shape, the gap is more to facilitate the admission of larger size particles. As they try to come down, their sizes are decreasing because they are taking the blows of the jaws, and thus their size is decreasing. When the sizes are decreasing, we should see that they will be entering in an area in which they should be entering at a lower area or a smaller area, which will be facilitating for them to take next blows, so that the particle size decreases. So hence the V shape is very important. A V open at the top. One jaw, the fixed or the anvil jaw, is nearly vertical and does not move. That is called as the stationary jaw. So stationary jaw is also called as anvil. Very good. The swinging jaw reciprocates in a horizontal plane. Please remember, the swinging jaw is moving only in horizontal plane. So it is moving left hand side, right hand side, left hand side, right hand side. So this will be moving. Now it makes an angle of 20 to 30 degrees with the anvil. So that he is telling the angle between the V shape. So if you try to draw a line of a stationary jaw with some inclination, and then you draw the swinging jaw, the angle made between them is around 20 to 30 degrees. It is driven by eccentric, so that it applies greater compressive force to the lumps caught between the jaws. So eccentric mechanism is used for delivering the force to the swinging jaw, which will be swinging from left hand side to right hand side. The jaw faces are flat or slightly bulged. Why bulging, sir? Because again we wanted to reduce the area. Say for example, during the due course of time, because of erosion, the particles, the surface area of the jaws may be decreased. So we create this kind of small bulge in that. They may carry shallow horizontal grooves. Horizontal grooves are, where are they there? They are on the faces of the jaws. As you know, just said that the jaws are made up of hardened materials, especially stone, but they are not smooth, but they are having some stampings on it. Rectangular stampings are there on it. Okay, these are called the grooves, which increase the concept of friction, and because of this, we can easily nip the particle. Once we nip the particle firmly, we can apply the force on the particle, and the particle breaks because of compression only. Remember, a Blake type of jaw crusher will be using compressive force only to break the size of the particles. Larger lumps, the larger lumps caught between the upper part of the jaws are broken, drop into the narrow space. Why narrow space? Because in the V shape, as I said just now, as we are going from top to bottom, the area is decreasing. Okay, the area is decreasing. Next time the jaws close. So when the jaws are coming closer, the process of crushing will take place. After sufficient reduction, what is the reduction, sir? The clearance between the bottom tips of the 2 jaws. That is important. So that clearance between these 2 tips of the bottom jaws are very important. So here I'll make one sentence here. As the product is falling down, again the product is also having a variation in which maximum size of the particle is equivalent to this gap. And minimum size, of course, we don't know anything, because if the size is less than this, without taking any blow, it falls from the bottom. So this is the meaning of it. And after sufficient reduction, the jaws open and close around 250 to 400 times per minute. So you can imagine how fast the jaws are moving. In 1 minute, 250 times to 450 times it is moving. So you can imagine how much amount of forces it is applied and how fast they are functioning. Remember, at least that whenever the jaw is going in the away from the stationary jaw, crushing will not take place. Whenever the jaw is moving towards the stationary jaw, crushing will take place. This is the law. But we cannot have such much amount of time because in 1 minute it is moving 250 times to 400 times. So definitely the crushing will take. The most common type of the jaw crusher is blade type of jaw crusher, which is shown in the figure. In this machine, an eccentric drives a fitment. So who is driving the machine? First, an electric motor drives. With the help of a pulley, with the help of a belt drive, the torque is transferred to the jaw crusher. In the jaw crusher, we will be having a central shaft. Other end of the central shaft will be having a flywheel. On the other side, we will have having the mechanism. And in this mechanism, the eccentric is connected, eccentric is driven by means of a fitment. So the machine, in this machine, an eccentric drives a fitment. Why eccentric? Because we don't want to make a circle. Because remember, the pulleys which are there, they are circles. So one is making a full one rotation. If the diameter is same, the second one is also making the same rotation. That is not we require. We want a vertical motion to be induced. So for this purpose, we are having the eccentric mechanism. Then, in this machine, an eccentric drives a fitment connected to the two toggle plates, which are giving very base support from the bottom. Because as the swinging jaw is moving towards the stationary jaw, in between there is solid particle here. But it should apply forces. So how to apply the forces? Who is applying the forces? Machine is applying through the toggle plate. So toggle plates are robustly clean sheets, okay, steel sheets, which will be pushing the swinging jaw from the back side, so that satisfactorily the compressive forces will be acting, and then the particle breaks into pieces. In this machine, an eccentric drives a fitment connected to the two toggle plates, one of which is pinned to the frame, the other one is swinging to the swinging jaw. So as I said that there are two toggle plates are there. Okay, let's see once again. Yeah. So there are two toggle plates are there. The one is pinned to the machine. This will not be moved. This will not be moving. Whereas this one will be moving. Remember, I said this is not moving, but even if it moves, also very small here. But how this movement is there? Because I said this is just vibrating. Remember this. This is just vibrating because it is not moving in inches or centimeters. Just slightly it goes and comes back in 250 to 400 minutes. So because of these vibrations, we are going to give a much important to the foundation also, so that the losses will be minimized and then the noise is also reduced. So these two toggle plates will be applying the force, the eccentric mechanism, the eccentric motion will be converted to these kind of gyrations per minute by means of this toggle plates. If I have a video of this, I will again share it with you. Don't worry. But I think you have all studied the engineering drawing. So in the ND1 we have a diagram called as slider crank mechanism. If you see that, you will understand about this concept. Don't worry. If it is possible, now we are in the college to show the videos to you. Here the bandwidth is very less. I am not able to use it. Still I am using my own application for this. If it is possible, I will be sharing the videos with you. I will be sharing what is the meaning of an eccentric mechanism, how the circular forces are converted to these kind of variations per minute. I will try to share it. If not, we can see in our laboratory also when you come back. Physically also you can see how the forces are converted. Don't worry about that. Yeah. The pivot point is at the top of the moving jaw and the above the top of the jaws on the center line of the jaw opening. So the pivot is at the top, and then remember it is at the center of the jaw crusher is like a swinging jaw is like this. So at the center of the central axis, if you draw it, here we are going to have the pivot. Then the greatest movement of the greatest amount of the motion is at the bottom of V shape, which means that there is a little tendency for crusher of this kind to choke. As I said just now, that in case of a dodge type of jaw crusher, the pivot is at the bottom. So the maximum travel will be at the top. So the swinging jaw moves back and then comes back. So the V shape, if you see the area, it will be increasing. So unfortunately, if a bigger particle falls, then coming back will be difficult for it. So crushing will not take place. It is called a choking. But in case of blade type of jaw crusher, the swinging jaw, the pivot is at the top. So it will have a restriction. I will take only this much amount of area, not beyond it. Similarly, in our mesh also you see it. If you have a mesh whose clear opening is 1 centimeter, 2 centimeter cannot pass through it. But 1.5 cannot also pass through it. But 0.1 can easily pass through. Or any value which is less than 1 centimeter can pass through it. So like that, the clear area, if you see the V shape from the top, you are going to see a square or a rectangle. So if the particle can pass through it, it will be crushed. So there we are having a limitation in the blade type of jaw crusher. Yes, the blade type of jaw crusher will be accepting only those kind of particles if they are able to pass through these two narrow points. If not, they cannot pass through it. Now we have to have an additional system which will crush the materials and then send it to the system. So because of this limitation, it's good thing because crushing will take place continuously. Thus, it is prevented from the choking. So when the choking is not there, what will happen? The machine is given the energy and the energy is transferred for creating new surface area. Yeah. The greatest amount of the motion is at the bottom of the V shape. For which one? For the blade type of jaw crusher, which means that there is a little tendency for the crusher of this kind to choke. So because they are able to move, means for there is a clearance is there, because there is a variation there in the product size, then definitely the crushing will take place. Once again, I will explain you. So for example, if you see this diagram, the pivot is at the top. These two ends are fixed. We put a particle to it. Then what will happen? Because of this jaw coming this side, as the particle is coming down, it goes in between the gaps and then crushing will take place. And they have to come down. For example, if this variation is very short, then what will happen? Unless and until the particle takes a blows and then break down, it will be staying inside the system for some amount of time. So if you put feed continuously, what will happen? The filling will be there up to this point, and the chance is there that material may also come out from the system. So to avoid that, what we have done is we have given a small clearance. If the distance between, suppose the swinging jaw is coming to stationary jaw, the clearance is 1 millimeter. If the swinging jaw is going away from the stationary jaw, it is 1.5 millimeter. So you can have 1.5 millimeter particle is also going, 1 millimeter particle is also going, and if the size of the particle is less than 1 millimeter, that is also going. So we are giving more flexibility for the product to go out from the bottom side. This will save the machine from choking. Remember this. Now this concept is not there in the dodge type of crusher. So because the dodge type of crusher, this size, this is 1 millimeter size, is fixed. Unless until the size of the particle is less than 1 millimeter, it cannot go from the bottom. Till then, it will be staying inside the system, occupying the space. Since it is occupying the space, it will not allow other particles to come in. And you are thinking that the particles can be added continuously to the machine. And as the pile-up takes place, it may come out from the crushing zone, and a pile may come out in the form of this. And thus, crushing is not taking place, energy is lost. So that design of blade type, dodge type of jaw crusher is an absolute one, and the new one is called as the blade type of jaw crusher. This blade type of jaw crusher is there in our laboratory. Yeah. Some machines with 1.8 to 2.4 meters feed opening can accept rocks of 6 feet in diameter and crush approximately 1200 tons per hour to a maximum product size of 250 millimeters. See here, the clear opening is 1.8 into 2.5. So if you see the top view of a V shape, I said it is a rectangle, and a rectangle is characterized by means of length and breadth. So this is 1.8 into 2.4 meters. So this is the area of the V section if you see from the top, and any particles is passing through it, it will be subjected for the crushing. And now as it is passing down, what is the maximum size of the rock which can accept? That is 1.8 meters. So here we have a limitation 1.8, which is the lower length, and 2.4 is the maximum length. So therefore, if this is length and breadth, length is 1.8 meters and breadth is 2.4 meters. So we have 1.8, then only can pass through it. So here he has given that the minimum size of the particle, sorry, maximum size of the particle which can be entering this kind of system will be 1.8 meters. But after crushing is over, see its size 250 millimeters. It will be becoming 250 millimeters. So you can imagine what type of primary crushing it is going to take place. And what is the mass feed rate? It is 1200 tons per hour. So you can imagine how heavy duty machines are, how the faces are hardened, how machines are giving power. So one common statement we can make, primary crushers will consume huge amount of energy because they will do a robotic work of compressing bigger sized particles. Okay, and smaller secondary crushers reduce the particle size of pre-crushed feed from 6 to 150 millimeters at a much lower rates of throughput. So once the material is coming out from the primary crusher, what we can do now? It can be sent to the secondary crusher. In the secondary crusher, further crushing will take place. But of course, the flow rates will be very little bit less than compared to the primary crushers. Okay, because as the size of the particle is decreasing, our main problem is nipping the particle is important. And since the nipping problem is there, unless and until the particle is crushed, we cannot allow the particle to go out from the system. Because of this reason, the mass feed rate of a secondary crusher is less than the primary crusher. Remember. Okay. Then comes the question of gyratory crusher. A gyratory crusher. So in the Blake type of jaw crusher, what is the problem? What is the small disadvantage which you are going to face? Whenever the swinging jaw is moving towards the stationary jaw, crushing will take place. Whenever the swinging jaw is moving away from the stationary jaw, crushing will not take place. So though it is moving and coming at the rate of 250 to 450 gyrations per minute, still there is a chance for compression is not, crushing is not taking place, but still it is consuming the energy. So the modified version of a Blake type of jaw crusher is the name of a gyratory. Gyratory. So this is the example of a gyratory crusher. Yeah. So here you have the feet which can be admitted into the system, main shaft bearing, spider arm, crushing head, maximum opening, again eccentric, and then counter shaft, gear, gearing, discharge, minimum opening, and then complete. So here this is the names of the gyratory crusher. This also will come in the examination. Don't worry about this. So the main thing is this shaft for us, and this shaft will be having a crushing head. Okay, this shaft will be having a crushing head. What type of crushing head? It will be a circular crushing head, or we can have a cylindrical pipeline. First what you do, you make a stainless steel rod as a shaft, and over that you introduce a circular disc or a cylinder from the surface, which is able to move. So hence that is made up of the stone. So hence that is called as crushing head, and this crushing head can rotate like this. And now this system is in a V shape. So this is the concave. Okay, this is a V shape, and here also we have liners of the rock. Okay, so now when this is moving, so how does it move now? Now as in the previous case, same case, because of the eccentric, this system will move like this. And this is a V shape. This is another V shape. So when the crushing head is moving this side, what will happen? Crushing will take place in this chamber. When the system is moving in this, then the crushing head is moving like this. Then the crushing will take place in this chamber. So at any instant of time, crushing will be taking place in the gyratory crusher. Means what? The problem which we have faced in the Blake type of jaw crusher is irradiated or removed in the new design called as gyratory crusher. So when the crushing head is moving in this fashion, we will have minimum opening, and here you have maximum opening. This is the crushing head. And one more advantage is here is there. So with the help of these screws, we can open it and then see if any crushing is taking place or not there. So this is the spider arm. So every glass and reactor will be having a spider arm. Then once a heavy material is fallen, what will happen? Then when you send this side also, it is not crushing. Then the crushing head will start rotating. So when the crushing is rotating, what will happen? The shear forces will be applied on the particle. Remember, whenever the compressive strength of the material is more, the only mode of breaking the particle is applying shear forces. This is the reason why a stainless steel rod, its size will be reduced by means of filing, not by cutting, not by compression, whatever is it. Only by filing we can reduce it. How do we do filing? Keep it in a bench wise, firmly fix it, and then apply the file over the length. We can reduce the area, length, whatever it is. So by grinding we can do this. What is grinding? It is a method of applying shear forces on the surface area of a specimen. So unfortunately, if a feed of different compressive strength, different nature is entering the system, no need to panic, sir. So this this crushing head which is rotating, that will start moving because of the slip. It starts moving, and thus the size of the particle decreases, and then crushing will take place and falls from the discharge. So here we have a gear because we have a shaft in this particular fashion, but this is at a distance. So 90 degrees it is there. So to change the torque, we are supposed to use a gear, 90 degrees gear. We are going to use it, and this is driven by means of a electrical motor. So this is the new modified version of a blade type of jaw crusher, coined as gyratory crusher. Okay, where at any instant of time crushing will definitely takes place. Okay, in the blade type of jaw crusher, crushing will takes place when the swinging jaw moves towards the stationary jaw or anvil. When the swinging jaw is coming away from the stationary jaw or anvil, crushing will not take place. So that kind of problem is removed in the gyratory crusher. Please try to understand it. So the modification of the blade type of jaw crusher is the second one called as the gyratory crusher, where one more additional feature which we have given to this machine is what? The crushing head is free to rotate on the shaft. So this will be facilitating us not only nipping the particle. If particle is not able to broken by means of shear forces, now that can be broken by means of shear forces. Okay, so if they are not broken by compressive forces, that will be broken by the shear forces. How shear forces are induced? Because this concave is not moving, this crushing head is moving. So one surface is not moving, another surface is moving. So this is how we generate the shear forces inside on the surface area of the particle, and then the crushing takes place. Yeah, gyratory crusher. A gyratory crusher may be looked upon as a jaw crusher with circular jaws, and between which the material is being crushed at some point at all the times. Whether it is going this side or that side, crushing will definitely take place. Whereas this is not there in the blade type of jaw crusher. So here in this diagram, when the when the crushing head is moving towards left hand side, crushing will take place and will have a minimum opening. When the crushing head is moving towards right hand side, there the crushing will take place and we will have a minimum opening. That side you will have a maximum opening. So opening is not at all altered, but crushing is ensured 100%. That is the modification of this particular design. A conical crushing head gyrates inside. Gyration means what? Having small reciprocations. Gyrates inside the funnel shaped casing, because as you try to go down, the principal fundamental is what? Its surface area, the area of the crushing zone should decrease, so that since the particle sizes are decreasing, even the crushing area should also decrease, so that the crushing heads will be nipping the particle, they will be applying the force on it, and the crushing will take place. That is the reason why we will have a V shape, and because of this V shape, the particles are caught even at the down whose sizes are small, and then the crushing will take place.